Welcome back. So, here's something that completely flipped my understanding of our solar system. I was diving deep into space documentaries one night. You know how it is when you start with one YouTube video and suddenly it's 3 a.m. and you're questioning everything you thought you knew about reality. That's when I stumbled across this mind-bending fact. Earth might actually have 2 moons. I know. You're probably thinking the same thing I was. What? Where's this second moon? I've been looking up at the sky my whole life, and there's just the one. But here's the thing that's been keeping me up at night since I learned about it. There's this chunk of rock about 3 miles wide that's been following us around for thousands of years, and most people have never even heard of it. Its name is 3753 Cruithne, and it's completely changed how I think about what's actually happening above our heads every single day. The story starts back in 1986 when this Scottish astronomer, Duncan Waldron, was doing his regular sky scanning at an observatory in Australia. Picture this guy, probably fueled by way too much coffee, staring at photographic plates through a telescope. He spots what looks like just another asteroid. Nothing special, happens all the time. He catalogs it, gives it the number 3753, names it after some ancient Celtic tribe called the Cruithne, and moves on with his life. But here's where it gets absolutely wild. For over a decade, 11 years, nobody really understood what they were looking at. It wasn't until 1997 that scientists finally figured out this thing's orbit, and when they did, it broke their brains. This wasn't just some random space rock drifting by. This thing was following Earth around the sun in one of the most bizarre orbital patterns anyone had ever documented. Think about that for a second. For 11 years, we had discovered Earth's second moon, and didn't even know it. It was just sitting there in our data, waiting for someone to connect the dots. Makes you wonder what else we're missing, right? So what makes Cruithne so special? Its orbit is absolutely insane. Instead of going around Earth in a nice, predictable circle like our regular moon does, Cruithne does this thing called a horseshoe orbit. When I first heard this term, I had no idea what it meant. But imagine you're looking down at the solar system from way above Earth's just sitting there, and instead of circling around us, Cruithne follows this weird kidney bean-shaped path that, when you map it out over time, looks like a horseshoe. Get this, the asteroid takes approximately 770 years to complete one cycle of its horseshoe-shaped movement around Earth. That's not a typo. 770 years. Your great times 30 grandchildren might see Cruithne complete one full horseshoe pattern. It's like the universe is playing the longest game of cosmic tag imaginable. Here's the part that really messed with my head. Cruithne orbits the sun in about 1 Earth year, just like we do, but it takes 770 years to complete this horseshoe dance around Earth, so it's keeping perfect pace with us around the sun. But from our perspective, it's doing this incredibly slow-motion cosmic waltz that takes nearly 8 centuries to complete. The closest this thing ever gets to us is about 12 million kilometers, roughly 30 times farther away than our regular moon. At its farthest point, it swings out to over 150 million kilometers. Its orbit takes it near Mercury and outside Mars's orbit. This rock has serious range. Now here's where things get technical, and honestly it sparked some deep philosophical thoughts for me about what we even mean when we say moon. Technically speaking, Cruithne isn't really a moon in the traditional sense. It doesn't actually orbit Earth directly. Sometimes it's literally on the opposite side of the sun from us, completely outside Earth's gravitational influence. What's actually happening is both Earth and Cruithne are orbiting the sun, but they're locked in what scientists call a 1-1 orbital resonance. I like to think of them as cosmic dance partners. They're moving to the same beat, staying perfectly in sync, even though they're not actually touching. Scientists have these fancy terms for objects like this: quasi-satellites or co-orbital objects. It's kind of like how you might walk alongside a friend down the street. You're both heading to the same destination at the same speed, but you're not literally connected. From an outside perspective though, it looks like you're together. And here's what really gets me from our perspective on Earth. It genuinely does look like Cruithne is sticking with us. Earth's gravity affects it just enough that we and this asteroid return every year to nearly the same place in orbit relative to each other. So while the textbook definition might say it's not a real moon, it's definitely acting like one in every way that matters to us Earthlings. If any of this sounds familiar, you might have caught it on that British quiz show, QI. They mentioned Cruithne in their Astronomy episode, describing it as Earth's second moon. I love that show because they're always dropping these reality-shifting facts that make you question everything. Even better, in a later episode, they mentioned that if you use the same loose definition, Earth actually has over 18,000 mini-moons. 18,000. Suddenly one extra moon doesn't seem so crazy, does it? But here's where my mind really started spinning. Cruithne isn't alone out there. As of 2024, we know about several current quasi-satellites of Earth, including ones with names like 469219 Kamo-o-Alewa and 164207 Cardea, plus a bunch of others with designations that sound like they came straight out of a sci-fi movie. The most stable of these is called Kamo-o-Alewa, and honestly, just try saying that 5 times fast. Scientists discovered this one in 2016, and they think it might actually be made of material that came from our regular moon, like a chip that got knocked off during some massive asteroid impact millions of years ago. How's that for a family reunion? Then there's 2023 FW13, which astronomers literally just discovered last year. This thing has apparently been our planet's cosmic companion since at least 100 BCE, and will probably stick around until about 3700 CE. This rock was tagging along when the Roman Empire was at its peak, and will probably still be there when we're flying around in spaceships. That kind of cosmic timescale just breaks my brain. If you're enjoying this cosmic rabbit hole as much as I am, definitely hit that like and subscribe button, because honestly, once you start learning about this stuff, it becomes impossible to stop. But wait, it gets even weirder. Earth also occasionally captures actual, honest-to-goodness temporary moons. These are small asteroids that get caught by our gravity and literally orbit us for a while before wandering off again, like cosmic hitchhikers. We've confirmed a few of these. 2006 RH-120 hung out with us from 2006 to 2007, 2020 CD3 orbited us from 2018 to 2020, and 2024 PT5 is actually orbiting us right now. These mini-moons are tiny. We're talking rocks the size of cars or small buildings, but they're genuine satellites, even if they don't stick around long. Computer models suggest this happens way more often than we realize. Some astrophysicists think that at any given time there should be at least one natural Earth satellite about 1 meter in diameter just orbiting our planet. So right now, there's probably some tiny space rock doing laps around Earth and we just haven't spotted it yet. Makes you wonder what else is floating around up there that we're completely oblivious to. So what would it actually be like to visit our weird quasi-moon? This is where my imagination always starts running wild. Cruithne is only about 5 kilometers across, similar to that comet that had the Philae lander mission a few years back. The gravity would be incredibly weak, like walking at a normal pace would probably be enough to launch you into space. Imagine having to move in extreme slow motion just to stay on the surface. You'd basically be floating most of the time. It's the kind of place where sneezing too hard could send you on an unplanned spacewalk. Even if you had a decent backyard telescope, you still couldn't see Cruithne. It's fainter than Pluto, and requires at least a 12.5-inch reflecting telescope. The kind of serious equipment that universities have. For size comparison, it's as tall as 5 Empire State Buildings stacked on top of each other, but it's still over 1,600 times smaller than our moon. So yeah, big enough to be interesting, but small enough that you'd never notice it without knowing exactly where to look. Here's something that's been keeping me up at night. These orbits aren't stable. Computer models show that Cruithne will probably spend only another 5,000 years in its current weird orbit. After that, things get really interesting. It might actually move into a true orbit around Earth for a while, becoming a genuine second moon, but only for about 3,000 years before escaping back into solar orbit. So sometime around the year 7025, our descendants might actually see 2 moons in the night sky. For 3 millennia, Earth would have twin moons lighting up the darkness. Then Cruithne would wave goodbye and wander back to its solar orbit, leaving us with just Luna again. But the story doesn't end there. In about 8,000 years, Cruithne is expected to have a close encounter with Venus that could completely kick it out of our cosmic neighborhood forever. So we've got this companion that's been with us for thousands of years, might become a real moon for a few millennia, and then could get permanently ejected by Venus. It's like the ultimate cosmic drama playing out over tens of thousands of years. This whole thing has really shifted my perspective on why any of this matters. Cruithne and objects like it contain what scientists call forensic evidence about how our solar system was assembled. Its bizarre orbit is basically a testing ground for our understanding of how gravity shapes everything around us over massive timescales. It's not just some cool space trivia to drop at parties, though it definitely works for that too. Understanding these objects helps us figure out how our solar system formed and how it's still changing. It shows us that interactions like this have been happening since the very beginning, shaping the cosmic environment we live in. From a practical standpoint, Cruithne could actually be incredibly useful. It could serve as a practice site for landing humans on asteroids and maybe even mining them for the rare metals our technology desperately needs. Before we send people to distant asteroids, we could use Cruithne as a training ground. It's relatively close, we understand its orbit, and it's big enough to be worth the trip. The really mind-bending part is that we're probably missing tons of these things. Earth apparently acts like this cosmic foster home, hosting all these wayward chunks of rock that are looking for a gravitational neighborhood to hang out in. Astronomers keep discovering more quasi-orbital satellites, some sticking around for centuries, others for just a few decades. And it's not just Earth. Venus has its own quasi-moon called Zuzve. Yeah, that's really its nickname because of a hilarious misreading on a solar system poster. Mars has 4 known co-orbital asteroids hanging out at special gravitational points. Jupiter has an estimated million of these things. A million co-orbital asteroids just chilling in its gravitational neighborhood. That scale just breaks my brain. Jupiter has a million cosmic companions, and we're just now figuring out that we have a handful. It makes you realize how much stuff is floating around out there that we're only beginning to catalog. What really gets to me is that this has all been happening forever, and we've only recently figured it out. It wasn't until the late 20th century that we even realized bodies could enter these weird horseshoe orbits and stick around for thousands of years. For all of human history, Cruithne has been out there doing its cosmic dance, and we had absolutely no idea. Ancient civilizations looked up at the same sky we do, tracked the same moon we see, and never knew there was this other object keeping perfect pace with us through space. It makes you wonder what other cosmic secrets are hiding in plain sight, just waiting for the right technology or perspective to reveal them. How many other mind-blowing discoveries are sitting right there in our data, waiting for someone to connect the dots? This whole deep dive has really changed how I think about our place in the universe. Our solar system is so much weirder and more dynamic than most people realize. Everything's moving, everything's changing, and everything's connected in ways we're still discovering. Earth isn't just floating alone in space with its one faithful moon. We're part of this incredibly complex gravitational ecosystem where rocks can spend thousands of years as our companions before wandering off to explore other parts of the solar system. We've got this whole extended family of cosmic objects that most people don't even know exist. And who knows? Maybe right now there's another asteroid out there, slowly getting caught up in our gravitational influence, destined to become the next member of Earth's weird collection of quasi-moons and temporary satellites. The next time you look up at the moon, just remember, it's not actually alone up there. Somewhere in that darkness, invisible to our eyes, Cruithne is following its ancient horseshoe pattern, continuing a cosmic dance that started before recorded history and will continue long after we're all gone. We live in a universe absolutely packed with hidden wonders, and sometimes the most incredible discoveries are the ones that have been right there all along, patiently waiting for us to notice them. Earth's other moon is just one of those secrets, but honestly, it makes you wonder what else is out there, doesn't it? Thanks for watching yet again. Like the vid and subscribe so I can keep bringing you fresh content.